Good morning, everyone. Welcome back. This is week 7, day 1. And today we're going to start with a new topic. We already saw the multiplications between a monomial and a polynomial, multiplications between binomials, and we also saw 7 formulas of special cases. And now we're going the other way around. We are going to factor out this polynomials that I'm going to give you. I'll give you polynomials, and you need to find a monomial multiplying a polynomial, or two binomials multiplying each other, or a binomial multiplying a trinomial, and that's called factoring, okay? We saw that already in 7th grade. We had a sneak peek of factorization when we used the GCF. So the first thing that we're going to do is like to define, okay? Only define what a GCF is, because we already know the definition, but just in a case. GCF stands for what? For what does GCF stand?
Greatest common factor.
Very good, the greatest common factor. So that's what I'm going to place in between this parenthesis. Now, greatest common factor. What is the greatest common factor of a polynomial? Okay, of a polynomial. Okay, our greatest common factor is of a polynomial. Okay, is the number, the greatest number that can divide every single coefficient. Okay, of a polynomial. It may include variables if and only if the variable is in the same variable, okay? The same variable is in every term of the polynomial. With one term that does not have the variable, then it is not part of the GCF. But if all of them have the term, that variable in the terms of the polynomial, okay, then we pick the one with the smallest exponent. Okay. If it is in every single one, then we pick the one with the smallest exponent. So let's begin with that, with the GCF. Okay, so we're going to have, for example, 14x to the 3rd power minus 21x squared plus 35x. Okay, sometimes our GCF is just going to be a constant. Sometimes it's just going to be a variable. Sometimes it is a variable with exponent, and sometimes it's the product between a coefficient and a variable. Okay, and the variable may or may not have exponents. Just be careful that we're going to look for the greatest number that can divide every single coefficient. And we're going to pick the variable that has the smallest exponent if and only if it is repeated in every single term. So let's see. Let's go with the coefficients first. We got 14, negative 21, and 35. What is the number that can divide all of them? What is the greatest number that can divide all of those coefficients?
7.
7, very good. So I copy 7. What would be the variable? Is there a variable that's repeated in every single term? Is there a variable that's repeated in every single term?
Is it x?
The x, and I'm going to pick the one with the smallest exponent. So we got cube, square, and invisible 1. What would be the variable with the smallest exponent?
Invisible 1.
The variable x that has the invisible 1. So I'm going to say x. That is my GCF, okay? That's the GCF. Now, how am I going to factor out? Well, I'm going to factor out by placing the 7x right outside a parenthesis, okay? And now I will go divide every single term by the GCF that I just found. Okay, so 14x cubed divided by 7x. Remember, you divide coefficient with coefficient. And when we divide variables, according to the laws of exponents, we subtract the exponent, okay? So that's what we're gonna do. We divide the coefficients, and then the variable, we copy it, and we subtract the exponents. So 14 divided by 7.
Two.
How much?
2.
2. And now we got x cubed divided by x. How much is that? Remember, we subtract exponents. So that would be x to what power?
X squared.
X squared, very good. Now negative 21 x squared divided by 7x.
3.
Negative 3
X.
x, very good. Now I have 35x divided by 7x.
5.
Positive 5. And what happened to the x? Well, when we divide the same variable by the same variable, it basically disappears because it becomes so 1, and 1 times 5 is already 5. And this is the simplest factored form of this polynomial. Sometimes we can use more than one factorization form, okay? Right now, we're going to keep it to that part, okay? We're going to keep it there. Questions so far? No?
I have one question.
Uh-huh.
Do we not add the x in the 5? We just leave it like 5.
Remember, in this case, we're dividing 35x by 7x. We got the same variable in the numerator and in the denominator. And we know that when we have, for example, 2 over 2, that is how much? How much is that?
0.
No. How much is 2
Well,
divided by
1.
1. So if I have
Porque
x
no
over
duerme.
x, how much is that? How much is x over x? That will also be 1. Now I simplify the 35 over 7. That is 5 times that 1. It becomes a 5. So that's why I told you that it disappears, because we're doing this procedure mentally, okay? We're making this x a 1, okay? So that's why it's just the 5, okay? No more questions? Okie dokie then. Let's go with another exercise, okay? Let's go, for example, with negative 3x minus 10y. And I'm asking you to factor it out completely. What would be the GCF in this case? Is there a GCF that you can find? Is there a GCF?
No.
Are you sure there's no number that can divide all of those at the same time, all of those coefficients? No. How about -1? Can -1 divide -3? Can -1 divide -10? It can, right? The only number that we will never use as a GCF is +1, but we can use -1. So if I use -1, I'm not going to place a -1. I'm just placing negative. And I'm going to say -3x divided by negative. That would be positive 3x. Negative 10y divided by the negative sign, that would be positive 10y. So sometimes your GCF is only -1 or the negative sign because we make it invisible. Okay, why? Because remember, we try to work always with our terms positive, or at least the first term should be positive. And since we're writing it in standard form, we know we write it in alphabetical order and from the greatest exponent all the way to the smallest one. In this case, x goes first than y. So x was my first term and it was negative. And I wanted to make it positive. So that will be my GCF, -1 or in negative invisible one. Are we clear so far? Okie dokie then. Let's do one more, okay? For example, I have (4x cubed minus 21xy). What is the GCF of that? What is the GCF of that? Is there a number besides 1 that we just said that we're not going to use 1 as a GCF that can divide 4x cubed and negative 21xy? What would be the monomial that is the GCF? What would be the monomial that divides that? So there's no number, right? How about a variable? Is there a variable repeated in every single term? Which one?
X.
X. So we choose the one with the smallest exponent. That will be only x. We open the parenthesis and we say 4x cubed divided by x. Mm-hmm.
4x squared.
4x squared, very good. Negative 21xy divided by x.
-21y.
Negative 21y, very good. And that will be my final answer. Yes, Maria, that will be my final answer. And that is how we're gonna factorize using the GCF. Okay, now we're gonna factorize using special cases, formulas. Okay, we're gonna factorize using the special case formulas. We already have an index card with those formulas that we had, for example, a plus, and I'm gonna say a plus minus b because it's basically the same thing, equals to a squared plus minus 2ab plus b to the square. Okay, so you know that this is a perfect square. If it's an addition, the first sign is an addition. If it is a subtraction, the second sign is a subtraction. Okay, this is two formulas. Then we also had a plus b multiplying a minus b. We are going to have a squared minus b squared. Okay, we're going to start with those two special case formulas. I mean, those three. These are the squares, the formulas for squares. Yes, Abraham. Okay, so If I give you, for example, an exercise that says 4x to the square minus 9, what formula do you think we're going to use? In this case, there's no GCF because the only GCF that there is in common is 1. And we don't use 1 as a GCF, right? There's no other number besides 1 that can divide the 4 and the 9. And there's no variable common in every single term. So I cannot use GCF. But I can see and try to use a special case formula. Okay? Since they're giving me a binomial, probably I could use this formula, which we called formula 3, because this is formula 1 and 2, and this would be formula 3. We were using these formulas to go from the left to the right. We're going now the other way around, from the right of the formula, and we're going to find the left. Okay, so they're giving me a binomial, so probably I will be able to use this one. So how am I going to use it? Okay, I know that this is supposed to be, according to the formula, a to the square, and this should be b to the square. Okay, but now I need to find a and b, not a to the square and b to the square. So that means that I need to find the square root. Remember when we talked about the inverse operations of exponents? We said that those were roots. Well, now is when we are going to use those roots. We're going to find, I'm going to do it in green, the square root of 4x to the square. And I'm going to find the square root of 9. Why? Because in that way, I will be able to find a and b. Now, for example, I have the a squared. If I find the square root of a squared, okay, I'm going to, remember there's an invisible 2 in there of the root. I'm going to cancel that out with that invisible 2. And what do I get? I get positive negative a, but right now we're just going to use the positive. So positive a, okay? That's what we're going to do. We're going to find the square root of the numbers and of the variable. Now, what is the square root of 2? What number multiplied by itself gives me 4? What number multiplied by itself? 2. Exactly, 2. So the square root of 4 is 2. What is the square root of x to the square? Taking into account this.
X.
Very good. X. So the square root of a square is x. So a is 2x. Now what would be b? B is going to be the square root of 9. What is the square root of 9?
3.
3. Okay, so now that I found that, I know a and I know b. I'm going to use this part of my formula. Okay, this part over here. And that will be the solution of this factorization. So I'm going to say 2x and 2x, 3 and 3, and one parenthesis goes positive and one parenthesis goes negative. And that's one way of doing it, showing a procedure. Questions so far? No? It's just a little bit too thick. Let's do one more, okay? Let's do, for example, I'm going to show you a little trick over here. Right now, I'm doing the same formula. 2y to the 4th power minus 1. Why is it the same formula? Why is it formula 3? Because it is a binomial. So now I need to see if I can factorize it. It's a binomial with a subtraction, by the way, with a subtraction. If this was an addition, there's no possibility of factorizing that, okay? But it's not an addition, it's a subtraction. Okay. No, this is not, this should be 8, sorry. Okay, 2y to the fourth power minus 8. Okay, first thing is identifying that this is a binomial. That's the first thing. Okay, this is a binomial. Second step is to try and find if there's a GCF. Is there any GCF in there? What is a GCF in that case? 2, very good. So I open my parenthesis with the 2 on the outside, and I say 2y to the fourth power divided by 2.
Y cubed.
No, y to
To the fourth power.
the fourth power. Very good. Minus 8 divided by 2.
4.
4. Very good. Now, pay attention to the binomial. I got y to the fourth power minus 4. Can I still simplify that? Is there still a square root for y to the fourth power? Is there a square root for 4? Yes, there is, right? So what am I going to do is, this is another way of doing it. Copy the 2, because I'm doing nothing to the 2. I'm going to open 2 parentheses. And this happens when your exponent is not a perfect 2, like in here. It's not a 2, it's something else, but it's still even. If it's an even exponent, we can do this. We're going to copy the variable in both parentheses. We're going to divide that 4 by 2. Whatever exponent you got, you are going to divide it by 2. 4 divided by 2, 2. So I'm going to copy that as an exponent. So y squared and y squared. And now I'm going to find the square root of 4. What is the square root of 4? 2. So I copy the 2 in both parentheses. And one parenthesis is positive and the other one is negative. It doesn't matter wherever you place it. You could have placed this positive and this negative. And that is the final solution. Why? Because, yeah, y squared has a square root, which is y. But 2, there's no number that multiplies by itself will give you 2. So we keep it up to here. Questions? No? We're going to leave it here. We're not going to continue doing no more exercises, okay? We're going to keep it there. I'm going to leave you one extra exercise, only one. And you need to try and see if you can simplify it, okay? As many times as possible. Okay, this is an extra exercise. Whoever solve it for our next class, okay, and gives me the solution in our class, just like right now, will get extra points, okay? But everyone has to do it because I might open an assignment as an extra points for everyone in the platform. So you're supposed to do it. Remember, the first one we will always try to seek is the GCF. And if we can do it, then I'm going to change it, okay? It will be like that. Negative 3y to the 16th power plus 3. And what we need to do, yes, that's a 16. That's a 16 exponent. What we need to do is to simplify, factorize it completely, okay? To factorize it completely. Once that you do that, I will explain it again in class, in our next class. So don't worry. We will be able to do it. So questions so far? Okay, so this is it for today. Basically, we saw 2 methods of factorization, GCF and the factorizations of difference of squares and the combination of them both, okay? Next class, we're going to continue with factorization of another special case. And that will be it for today.